Hello class. In our yesterday's class, we have seen the quantum numbers and we came to know about the first quantum numbers, that is principal quantum number denoted by n, and azimuthal quantum number, or we called orbital quantum number denoted by L. And we also came to know that how we can have the values for orbital momentum quantum number from principal quantum number. So if the value for n is 1, that is principal quantum number is 1, then the value for L ranges from 0 to n minus 1. So the value for L will be 0, like that. And if L is 0, then it is s orbital. Our previous classes. Now today we'll discuss about the two other quantum number, that is magnetic quantum number and spin quantum number. So first we are going to discuss about magnetic quantum number. It has been observed that a moving electron in a subcell is associated with a magnetic field. So when an atom is placed in an external magnetic field, the orbitals of same kind, that is px, py and pz, these are the subcells of p orbital, are no longer identical in energy because some of them are parallel to the magnetic field while others are not. As a result, electron gets excited from one of these orbitals to another and give additional lines. Okay. And like for orbital angular momentum, the value ranges from 0 to n minus 1. The value for magnetic quantum number, which is denoted by n, ranges from minus L to plus L. So in between that it will come 0. Okay. So minus L to 0 plus 1. Okay. Now say for example, when L equals to 0, the value for n equals to 0. Why? Because it ranges from minus L to plus L. Since its value is 0, it will be 0. Only one value. So that means a subcell will have only one value. Similarly, when L equals to 1, the value for M will be minus 1, 0, plus 1. Okay? Because it ranges from minus L to plus. Similarly, when L equals to 2, it ranges from minus 2, minus 1, 0, plus 1, plus 2. That will have 5 values. So the first when L equals to 0, it will have only one value. For L equals to 1, it will have 3 values, and for L equals to 2, it will have 5 values. Similarly, when L equals to 3, we can have from minus 3 to plus 3, so 7 values. Got it? So now what information will be given by this magnetic quantum number? So when n equals to 1, L equals to 0, m equals to 0. That is only one value of m is permitted, and S subcell is composed of only one orbital. Okay, similarly we can go for n equals to 2 in a similar way. Okay, then we'll come to know that the P subcell is composed of 3 orbitals known as px, py and pz. Similarly, D subcell will composed of 5 different orbitals, and F will comprise of 7 orbitals. Okay. Now, so that was about the magnetic quantum number. So we can find in that way. Now we are left with the last quantum number, that is spin quantum number, which is denoted by small s. Okay. Now, to explain the magnetic behavior, it was assumed that an electron spins around its own axis, and this spin creates a small magnetic field. Now, electron not only revolve around the nucleus but also rotate on its own axis, and because of this spin, it creates a small magnetic field. Therefore, an electron behaves as a tiny magnet. An electron spin can be either clockwise or anti-clockwise. Okay, it can have only two values, clockwise and anti-clockwise. And therefore, for S, that is a spin quantum number, can have two values, possible values, that is plus half or minus half. Plus half means clockwise and minus half means anti-clockwise. These values depend only on the direction of the spin. And as a rule, when two electrons are present in an orbital, these have opposite spins, up arrow or down arrow. Plus half is also shown by up arrow and minus half is shown by down arrow. So that is the representation of the spin quantum number. We have to remember that in an orbital, we can have only two electrons, and that two electrons will have the opposite spin. If one is plus, other will be minus half. Okay, plus half and minus half. Say for example, if you want to write down the spin quantum number, let us take this example only to find out its spin quantum number. When n equals to 1, the value for L equals to 0, and the m will also be 0. Now since over here we have got only one orbital, that is s orbital, we can say s subcell. Now for this one subcell, when m value is only 1, that is 0, it will be plus half comma minus half. Okay, plus half comma minus half, or together we can write plus minus half. Okay, so that will be the spin quantum number for this value. Similarly, when we go for n equals to 2, L can have a two values, that is 0 and 1. So separately, when L equals to 0, m will be 0. Okay, only one suborbital. Okay, and when L equals to 1, we can have three values, that is minus 1, 0 and plus 1. So when n equals to 0, then spin quantum number S will be equals to, as I explained, for one orbital we will have two electrons, plus half and minus half. Okay, or plus minus half, we can write together. And for m equals to minus 1, 0 to plus 1. So for this it will be plus minus half, for this will be plus minus half, and this will be plus minus half. So altogether n will have 6 electrons. Okay, this will have 2 electrons. In that way we can find the spin quantum number. Now today's assignment number 14. Question number 1. What information does magnetic quantum number m provides? And question number 2. Write all the possible values of azimuthal quantum number L and magnetic quantum number for the following principal quantum number: n equals to 1, n equals to 2, n equals to 3, and n equals to 4. So from this value we have already found the L values. Now we have to find the m values from it. Okay, from there. So next is, what are the possible values of its spin quantum number S? And after that, deduce all the possible sets of 4 quantum numbers when n equals to 2. That means when n equals to 2, now you have to find all the possible quantum numbers. That means the value for L, azimuthal quantum number, we will have to find for magnetic quantum number, and finally spin quantum number. Complete it and send it in.